I want to say good morning and thank you for joining us. I'm Claire Lewis, the Florida Friendly Community Statewide Coordinator. Today's webinar is on the topic of soil health and the importance of soil testing. Before we get started, I'd like to remind you to fill out the exit survey before you leave today. This gives us valuable information on how we're meeting your educational needs and what topics are of interest to you. We hold this webinar series the second Tuesday of the month for the remainder of the year. Our next webinar is Common Installation Mistakes of Landscape. It will be held November 10th at 10 a.m. with Aaron Alvarez. Your microphones have been muted upon entering the room, so please type your questions into the chat box and we'll take questions at the end of the webinar. With that, I'd like to turn the screen over to Tom Wickman to introduce today's speaker.
Thank you, Claire. I'm Tom Wickman. I'm the statewide Master Gardener, or excuse me, the statewide GIBMP coordinator. I was the Master Gardener coordinator many years ago, so it still comes natural to me. And it's my pleasure to introduce our speaker today, Dr. Rao Mylavarapu. Dr. Mylavarapu focuses on extension and research programs in soil and nutrient management. He directs the Extension Soil Testing Laboratory and Analytical Research Labs. He leads the Sustainable Nutrient Program. This is the first position ever to be filled by the Soil and Water Sciences Department with responsibility for developing and delivering highly visible programs aimed at promoting economically and environmentally sustainable agricultural production and minimizing nutrient impacts on water quality. The research component addresses critical nutrient management issues such as crop nutrient requirements, soil and tissue testing, nutrient-related environmental concerns, and interdependence with water management. His extension program again focuses on nutrient management and emphasizes environmentally responsible nutrient management in the production of major agronomic and horticultural crops produced in Florida. He's also a prolific author of research papers, book chapters, and numerous fact sheets. Today, Dr. Mylavarapu's topic is soil health, and I'm excited to hear it. So, Rao, I'm going to turn it over to you.
Thank you, Tom. I appreciate your introduction. Good morning to you all. Like Tom said, I am in Soil and Water Sciences Department in Gainesville. I run, my program is called Sustainable Nutrient Systems. I have been here for 22 years. And I'm also, a part of my job is to oversee the soil testing lab, which we all know as Soils Lab, but it's a major research component and also an extension component. So we got to take this whole process. However, the analytical procedures that are used for researchers, grad students, or faculty members of research programs for our extension activities are exactly the same, follow the same quality protocols. So it's a very high quality meritorious program that this serves. And extension soil testing program is one of the largest extension programs in the state. This also has a complementary, another section, which is waste testing lab. Some of you may have known about it, or if not, there is a component other than lands and water samples that we analyze. We also analyze compost samples and other waste material, manure, etc. Through another section of these labs. And because there is a compost aspect to it, which are usually used in some of our landscapes and some of our. Let me start talking about a little bit about the soil health and how it relates to Florida landscapes.
Dr. Rao, could you try turning off your video because your sound is lagging and sometimes that improves the connection quality.
You think so? Okay, I can do that. I'm just having a little difficulty in moving this forward, these slides. I think maybe you might have to help me over there. I can turn it over to you, and I can stop sharing. Maybe
All
you
right, so
can.
Dr.
Can you
Rao,
do that?
if you'll
It's
try
kind of
clicking on,
stuck. You know. Sorry.
try clicking directly on the presentation slide and using your arrow keys.
Yeah, I did all of. Oh, yeah, it goes now. It's just a little bit of there. Thank you. Anyway, just to give you a historical perspective on this of the soil health. Soil health, has been known to people for a long time, and actually for many centuries, because that's how it started before we went into the synthetic fertilizers and all the commercial aspects of it. That we need to kind of protect the soil and its wealth and its health and the quality. So basically what we are talking about is that we need to build a microclimate that will support the microbial populations. And previously, it was all agricultural production, so it's food crops. That's where it was originally focused. We usually show a live earthworm in soils, kind of attracts attention that they are healthy and then moving about in the soil. That we consider more like a healthy. There is a lot of recycling of organic through the composting process, nutrient recovery, because there is a lot of material out there, organic, particularly the yard waste, etc. Contains a lot of nutrients. Even the vegetable peels that we throw away or the other food products that we kind of throw away actually contain a lot of carbon, a lot of nutrients, but the release pattern is not that simple. So therefore, the question of how to apply them and how to compose them to turn them into something that will be quickly available to the plants is an aspect that we work on. So, but this will add matter and then add other aspects to it, such as quality and soil properties improve because of that. And probably a decade or just over a decade, we have been transitioning in terminology. We started calling sustainability. Then, we talked a little bit about soil. Then, we have now currently soil health as the focus area. So we need to be able to distinguish a little bit. And even, if there is any difference, sometimes, they overlap quite a bit. So let's look at the definition. So definitions that we have, the USDA NRCS, the Natural Resources Conservation Service, they define soil health. We should be able to first define any term so we understand the scope. So that's what this helps. This is, they say the soil health is also referred to as soil quality. And this is the continued capacity of soil to function as a vital living ecosystem. So it's an ecosystem that's a living ecosystem that sustains our use for systems, that is plants, animals, and humans for various things that we do on this land in these ecosystems. So this is a very broad and much more wider scope they have defined. And professional society of which is the Soil Science Society of America also defines it as soil quality as the fitness of a specific kind of soil, because all soils are not equal, all ecosystems are not the same. So as you get to the professional, to dissect them and then distinguish different aspects. So they are very clear that it is a specific kind of soil, not all soils. A group of factors that certain condition or a certain soil, certain location. And then the function within its capacity and within the natural managed ecosystems. It's either natural or managed, because most of our, in this case, yards, our landscape, they are managed. They're not natural. But there are out there natural systems that we do not necessarily touch, and we let them do their thing. So in either ways, we have to keep the function and its capacity to sustain the plant animal productivity, maintain and enhance water air quality, and support human and habitation. So when we talk about humans, and we are just talking about all the microbes, all the bacteria, all the fungi, everything has to sustain in its own ways. So it's not like one of them will take over and then try to manage their populations. So that's how this is the background. Let's look at, what soil health and what are we talking about. So this is the definition. This is a conceptual framework. But then when we come to the real nitty-gritty of it, the grainy parts of it, its difficulty is not just conceptualizing, but conceptualizing, determining it as per the definition. So I mean this soil health, and it is a multi-parameter aspect. It's not just one or the other. And then these parameters have to be measured, quantified. Again, like I said, under what circumstances, when and for what duration we have to measure, when that will start making sense for the ends that we have for the eco. And then if the distinct data points that we collect, usually there are several, and then there are several parameters, not one directly relates or it's the soil health. It's an index, that's what we call an index. Every time we hear the index, usually it's a multi-parameter issue. It's not just one parameter. It's not like one measurement you do. You got to do multiple measurements and make sense out of those, all of them, and integrate that result and try to manage them in that overall comprehensive manner. So that's when it becomes an index. So if this is an index, and then how the data are integrated and how easily is it comprehensible. So end of the day, a user or a person or a commercial grower, even an average homeowner out there, is not even in the landscape, or they should be able to figure this, what exactly are they doing as their part that is affecting the overall sustainability and soil health. So coming to Florida landscapes, you've probably seen this a few times. If you're not, this is the latest IFAS Resources and Economics group has put together. The estimated area is about 5 million acres of, if you consider the residential and other landscape. This does not include the golf courses, etc. Those are different. But any office spaces or other commercial establishments have landscapes, and that is approximately 5 million acres. And it's always increasing as our urban areas increase. These areas also increase, and roughly it's estimated that about 3 million acres area, when you put together, it's a lot. In an average yard may look to a homeowner as pretty small and manageable, but when you put all of them together in a town, in the state, they become huge area. This is an estimate that we have, and like I said, this number keeps on changing. But the perspective, we need to have some idea about what are we talking about. And then this has these issues. Every time a landscape is managed by not professionals, but homeowners and others, these issues become important. And what are those? The yard. And a lot of people, do not necessarily have a good idea about what kind of area they have in their yard, and what kind of mixes of lawn grasses, plants, and trees, different species that you have. And then the mix they have, that is a very important factor someone has to understand. And then what are the synthetic nutrient sources? One is organic, you apply organic sources. But then there are also synthetic nutrient sources which you just buy off of a shelf in a fertilizer stores or in a Home Depot, Lowe's type of locations. And then there are herbicides that we have to manage, and there are pesticides and fungicides on top of that. And then there is recycling of grass clippings, and how green is green, that can be argued till the cows. And grass species, it's not necessarily that, you have various plants, but which one are those and what are the species? And the soil conditions, because remember, this is a soil centric, we're talking about soil health. So this is a soil centric discussion that we are having. And, philosophically, we tell students, that we come out of the earth, we go back into the earth, basically come out of the soil. Everything that we are made out of is back, actually, if we break down, it is all in the soil, in the earth. And then everything, we just, recycle back. So that's how soil conditions are directly impacting. This is just to give them, a kind of a jolt when they come to us to understand what they're talking about and why this is important. And then all of these big factors become very important when you're managing your yard, any yard. So do we know? So in this, given this background, approximately say if 3 million are managed by the landscape professionals, there are more acres combined that may potentially benefit from some kind of a science-based input on the management. So that's where we all come in. So how do we help this process, and how do we educate, disseminate whatever we know? And not that we have answers for everything, but we are starting to look at each one very carefully in the last 2-3 decades. So things are getting focused, and it's just not, now that counties are also jumping in with various, ordinances. So we have to consider all of that, because everything is towards this soil health and other quality that we want to maintain. Given that, we have to first understand what kind of soils we have to begin with. What are we talking about? So this, I always use some of these slides everywhere, because it kind of gives you an idea of what the diversity in Florida that we have. This map that you're looking at is the map of the soils in the US. All the colors you see actually denote various types of soil at the highest level, which is the soil order. Various soil orders occur. There are about 12 of them around the world. And in the US, we have almost all of them that we deal with. And if you look at, around in the Florida state, you can see the colors that it denotes. So that's kind of soils we have. There are others that show up on this map, but this is the most predominant soil. These are the most predominant soils that we have in the state. This particular map kind of shows the elevation that we have in Florida and how that has driven the development of our soils. If you see in the panhandle, the redder color, the reddish change is all ultisols. Ultisols are one of the oldest soils. They are good soils. They have to distinguish it to an extent. But then, as you come down around in Gainesville and other Mid-Suwannee, and we have alpha, which are the next best. And then as you go down south in the center part of the state over, say, Highway 27, if you're driving down on the turnpike, you're on 27, if you are pretty much on the antisol section of the state, which is the highest point where we have a lot of sand piled up. And as you travel down south and both towards the coast. The depth of the soil tapers towards the coast and towards the south. And as we go to more towards the south, we have Everglades, where the soil level is lower than, elevation is lower than the mean sea level. Therefore, this water, flowing through all these other parts of the state to this section doesn't have any place to drain out to. So it's a lot of fresh water sitting there. It's like a huge basin. That's what we have in the Everglades section. So this is what we are dealing with in the soil in Florida. And wherever you are located, please keep this in mind to an extent. If you've seen this, but that's fine. But I want to emphasize again, I do this every place. This is a reason of our soils, which are on 4 corners here. And then the one is best soil, what is considered in the world, that is called Malisol. I'm just taking an example from Iowa. And we are now comparing percent silt and clay. This is also called texture. And you can see the percent silt and clay, on the left side. As you see this antisol, it has 3 and 3. There is no horizonation. It's all sand, sand, sand. All up here in where I am, which is around Gainesville and North Florida part of it. We have sand in the top, and we have a little bit of clay, which is about 23%. Compare these, as you're looking through, compare this with the Iowa Malisol, what they have. They have 98% sand, silt and clay, and 98% silt and clay at the lower horizons too. And this is another sporosols along the coast, both in southwest Florida, and other locations in northeast part of the state. We have this soil, which is a very shallow soil. You can see the water table standing. If you come back in certain seasons, you will see the water table all the way up on the surface. Sometimes it's drained, and this repeated draining and immersion causes this sand to completely strip off all the chemicals. So this white that you're seeing is not that anybody painted it white. It is the reflection of the sand particles that are on the surface. So here it is, just 2% of sand, silt and clay, and further down it is 5%. Everything that was up here has actually moved down to this layer, and this section has become so hard that it's just not possible for any of the roots to reach out or even. This is extremely harder layer. This has some good organic matter, iron, aluminum, and other nutrients here, but there is no way, the roots are even penetrate this. So it is kind of sitting here. So we manage these soils in a different manner. This is the largest type of soil we have, sporosols in the state. We are known for that. And then this is approximately in Florida that is under cultivation of some kind. The total age for this type of soil, 8 million acres in the state. The other one, Altisol, this kind of soil you find in the Panhandle, where you see some clay right within the reach. These are one of the older soils and well weathered. So you have a little bit of organic matter on the top, but then there is a quick layer of clay at the bottom. You will see the same here in Altisol too, as it transitions into
Hi, everyone. Give him a second. It looks like he's trying to get back on. So it looks like he lost his connection. Tom, Claire, have you gotten anything from him?
No.
Yeah, I have not either.
It looks like he's here, but we have lost him, maybe.
Can you hear me?
Oh, now we can.
Oh, thank you.
We don't see any slides.
Can you see the screen or?
No, I can't.
Sorry.
Peter in the chat box said that the internet is experiencing very high traffic, and that certainly seems like it's a connection problem.
Sorry about that, but I'm trying to share the screen, but that's something. I have to probably get out completely and then reconnect, if that's okay.
You could also try sending me your email. I mean,
Yes,
sending your slides, and maybe I could pull it up.
Sure, I'm doing that as we speak. I just sent it.
We appreciate everyone's patience. We hopefully will get on in just a minute or two.
Oh, can everybody see the slide?
Yeah, I can.
Okay.
Yes.
And do you happen to remember which slide you were on?
Yeah, I think just keep going. I'll probably point out.
I remember that.
Right. Yeah, somewhere here. Yeah, thank you.
Okay, just tell me when to advance.
Yeah, I will. Thank you. I have to. Thank you again. Sorry about that. This issue here. When my internet connection says everything is okay, but I don't know, something else is happening probably. Sorry about that. And then here is the organic matter content. You can see around our Florida soils, we have less than 1% or around 1%, compared to 3% in Iowa Malisol. 3% is a lot of organic matter, 3 times more organic matter in the top soils. And then even as they go down the profile, it is still, pretty higher than what we have in Florida. Next slide, please. Next slide, please. Oh, thank you. This is the water holding capacity. And same thing, you can see our numbers in the single digits. And, over here, it's 3-4 times more than what we have in Iowa. So this is the type of soil we are dealing, these are the type of soils we are dealing with here in Florida. And all of this area in Florida comes under what's called a coastal plain soil, which extends from south of Delaware all the way to Texas and a little bit north of there. So this area is all coastal plain. Another state that is full of all, entirely coastal plain soil is Mississippi. Next slide, please. And then here is another thing, all that soils we learned, okay? We have some comparison. Now look at this, what happens in a yard. And all that we studied, but here is the leveling part. They sometimes dig up and re-level the soil. They sometimes bring other soil from outside, topsoil or sand, and then that's used to develop the neighborhoods. So this is the biggest challenge we have. We think we know the soil and we know the soils. We think we know we know how to manage those for other purposes, which are not, almost similar to what I have shown. But when it comes to landscapes and then residential areas, this is what happens. So this is a much, much bigger challenge for us to understand and follow. For those of you who wonder what these white concretions here that you see are, these are the calcium carbonate concretions that we have in Florida. We are sitting on a bed of lime rock underneath. So it's very often that this thing comes up to the surface, and it can affect our management and the conditions to an extent. So next slide, please. So now, given this, what are the parameters that we have to use for soil health? Yes, next please. So there are, because again, this is soil centric, we have to talk about soil mostly. Physical, chemical, and biological properties. These are the three things that we know that we can talk about in Florida. And then next please. Now soil, what are the physical parameters we are talking? When we talk about soil texture, that is sand, silt, and clay, soil structure, how they are grouped together, the bulk density, how hard they are for penetration, porosity, how much pores they have, the soil water, porosity depends on soil water depends on the porosity. Same thing with the soil air, how much pores there are other than the mineral matter that can help diffuse air through it, and then also percolate the water. Then we have aggregate stability. How stable are these little aggregates that are formed in the soil, because that is needed to support the root system and the plant system to stay erect. And then the soil color, not so much in Florida because we are a pretty sunny state, but there are areas in the country, the soil color, darker the color, the warmer it gets in terms of soil temperatures. So that is also important. Infiltration, hydraulic conductivity, how much water goes through that every time it rains or every time you irrigate, and what is the conductivity of that soil once it gets through the surface. Does it move or does it stagnate, and then that causes anaerobic conditions and then fill up all the porosity and not leave enough space for air to also move. Next, please. These are the physical parameters. Soil texture, like I said, is also called soil type. If we hear about soil type, this is what it is. Soil texture is what they're talking about. It's also called particle size distribution, how this particles such as sand, silt, and clay are distributed. What is the proportion? What is the proportion? 100%, 20%, 30%, what it is. Then comes the soil bulk density and porosity. How dense is the soil packed? You saw the other slide where there is leveling equipment, other equipment that comes through the particularly residential or other landscapes, even in a major neighborhoods. That's how it is done. And during that time, it can be packed. It will be very different from the natural bulk density, if it was occurring out there in the native soils. So that has to be a little bit understood, So, and this is the weight over volume. That's how you get the, per a given volume, what is the weight of soil that you have in there. And once you get that, that's called soil bulk density. This density is very important. But however, one good thing is once you have some sense of what the bulk density is, you can easily calculate the porosity. I have given the formula at the bottom of this slide. That is percent porosity is just a multiplication and a little bit of math. And that gives you the percent porosity. The PD, luckily, all you have to know is the bulk density, the PD, which is called the particle density, which is just the weight of the sand, silt, and clay particles without the air, without the water, anything. So that is called particle density. That is always a given unless someone tells you differently. It will be a 2.65. So if your bulk density was 1.3, for example, and then you do this, so it will be about, the answer for this formula will be about 50%. So 50% of your area of your soil is porous, and the other 50% has soil and mineral matter. So that is very good. So you can use out of that 50%, a little bit for organic matter, 1 or 2%, and then you can have enough of air and enough of water circulating through. That's extremely important to keep track of that. But that's the measurement we can do to find out how healthy the soil is, how well it is doing. Next, please. And this is the textural triangle is what we call. And this is how the various clays and soil textures are actually graphed. And if you click one more time, please, you will see that, go back, please, one slide. Yeah, I see that red circle appear. Just one time, please, a click. Yeah, that red you see on the leftmost side of the triangle, that's where we are. The whole state is sand. And all the remaining chart, we don't even go anywhere near. So that's why we are called coastal plain sands. So that's what the challenge is. But then, since it is also sand, a lot of it is sand, we can probably manage it in a different way. We cannot use the same that we use for clay loam or loam that other states have. Sandy loam would have been the best soil. Like alphasols will have some of that, but not in Florida. So this is what the textural triangle gives you as an idea about what kind of soil you have. Next, please. So now this soil texture and some of the organic matter, and then some of the iron and aluminum compounds, these together, give some, are like cementing agents between the sand particles and silt particles and clay particles. They kind of form a little bit of aggregate, small clods of soil as you dig through them, or as you plow through them. So that's used for those aggregates, like I said earlier, are very important for providing enough density in the soil and enough support in the soil, strength for the plants to grow up, for the roots to take anchor in, and then also for the nutrients and water and air to go through. They will leave enough pore spaces both on the surface and below the surface. So aggregation is very important. But unfortunately, we have coarse textured soils or sandy soils that cannot necessarily bind very well, and we don't have enough organic matter. So therefore, we have very poor structure or almost no structure. We call them grainy sometimes. So therefore, the drainage will be very high, most of these places wherever the soil is deeper. If it's not, it just starts pounding and then goes up onto the surface to flood it. And then there is no penetration resistance. So there is a chance that if you don't pack the soil well, the plants can fall over, at times. So next one, please. Now going to chemical properties, we need soil pH. We call, whenever you hear the word soil reaction, they are referring to soil pH. And then the next one we need to talk about is the soil organic matter. We'll talk again about this. Soil organic matter, how much organic matter is there will help because we don't have any clay. Say, for example, if we had clay would give you a cation exchange capacity, which is the nutrient, like, that will hold calcium, magnesium, potassium, sodium. Just give you a relative number. If this is in sand, in our soils, our cation exchange is less than 10. Whereas if you had some clays that some of them, even if you went up to Georgia, you have the Piedmont clays where the CCs can go up. But then if you went really to say Iowa, go back to Iowa, for example, or most of the Midwest and other northern states, the CEC can be with the clay. If you had some montmorillonite type of clay, this number could go up to 100 and 150. Vermiculite could be 100, 150 compared to ours, which is less than 10. So that's where the organic matter becomes important, because organic matter give you 300 of this number instead of 10. So a little bit of organic matter will do a lot. Even 1% is a lot of organic matter compared to. However, any more that you can keep is better. And then now in the soil for the chemical properties, we also need to know what kind of nutrients it has, what kind of acidity it has, what kind of holding capacity it has. So we use in Florida, we use something called malic 3 extractant for all acid soil, which is predominant area in the state. And then also for Miami-Dade, recently we got an approval. Even though they are calcareous, we found our research showed that malic 3 worked very well. So the IFAS Plant Nutrient Oversight Committee has given us the approval a few months ago. Now we have switched to malic 3 for that soil also, for those soils also. This is just for Miami-Dade. It may expand to other locations a little bit later. Here the pH in Miami-Dade is as high as 7.5, 7.8, and 8 in some cases. Acid soils will be less than 7, more like 5, 6.5, etc. And then with this type of method, we find out how much phosphorus, potassium, calcium, magnesium, sulfur, copper, manganese, zinc are there in the soil that is kind of available to the plants. This is not the total amount, but this is how much it's available. Next slide, please. Now the biological properties, the organic matter returns, because it is organic matter. Organic matter is, you can recognize because it has carbon in it, okay? Organic carbon. And then the total and mineral nitrogen, how much of that? This is different from organic matter. Organic matter, like I said, gives you carbon, which is C. And the other one is total nitrogen. So the CN ratio, the ratio between total carbon and total nitrogen is extremely important for any of the fertilizers or any of the organic sources that we utilize, or even if we do not use organic sources, even in the natural system, that ratio is automatically maintained. If that ratio is below 20, you can see that all the organic matter is slowly turning over and then turning the nitrogen into mineral nitrogen. Mineral nitrogen is nitrate and ammonium. These are the two mineral species. Otherwise, it is in organic carbon bound nitrogen, like any of the tissues, any of the manures, they will be originally in organic form. They slowly convert over, which is called mineralization, into these inorganic species, which is nitrate and ammonium. So that is extremely important. Then the microbial respiration, how much respiration is going on in the soil. There are a couple of issues with that. I might try and talk about it a little bit later. But then we also test for active carbon, which is also, if you see a word POXC on any of the reports, that's what that is. And then they're also trying to find out the soil proteins. And then now, in the recent times, we have started discussing in the department with our microbiologists, is there a microbial specificity test? I'm going back to microbial respiration and then connect this to this aspect, the specificity part of it, because when you do microbial respiration, it is respiring. Most soils do. There is some microbes always, there's some millions of them. But then how specific are these? What kind of microbes are those? Do we know, are those useful or not so useful? So then some of them were suggesting recently that, should we go for a more genetic test and find out what kind of diversity in the microbes do we have? Because the diversity is always important. So is that something we have? Next, please. And then now I'm just going to quickly show you two soil tests that we have, two soil health tests that we have in the area, in the country. These are the two particularly I refer to because Auburn is very close to where we are. It's also in the coastal plain soil, some of it is. So we are in the southern part, which we share the similar climate and rainfall. So I'm going to show you that. And then another one is Cornell, which is way up in the north. They have, these people have their definitions in the process. Next one, please. Auburn soil test. Let's look at it. This is a routine soil test. Whatever I showed you earlier, the malic 3, we get all those potassium, calcium, magnesium, etc., phosphorus. And then they also look at the CEC, base saturation, and soil group, what kind of soil that is. And then they also look at micronutrients, like I told you, copper, iron, zinc, manganese, boron. And then they may have some additional heavy metals like lead and cobalt and chromium and cadmium. These can be done in our lab here also, but only on request. But on a regular basis, it's not necessary. Same thing with cation exchange capacity. Whether or not you do it or not, unfortunately, we will be within the 10 number I told you for cation exchange capacity. So it really doesn't help to have the cation exchange capacity, although some of the private labs do put that cation exchange capacity CEC on the reports. It's an extra information, but that you cannot really change that. And then there is soil organic matter that we do, and everyone does that. Soil respiration test I talked about, aggregate stability and slaking, how much these aggregates are stable and how do they kind of decoalesce, so that way they disintegrate. So another one is EC. EC is the electrical conductivity, that is the salinity in the soil. There are some areas now around the coast now, which is one of the reasons why the pH may also increase in Florida rather than what it's supposed to be, because there is a lot of this seawater and saltwater intrusion happening in those areas. And also some of the water is turning because we have applied a lot of fertilizers and nutrients that kind of is very salty. That can also increase the electrical conductivity. But I have several fact sheets talking about all of these if you look in the EDIS. And the trick is to be able to spell my last name. That's the only thing. But anyway, if you can, you will be able to look at several of these. Next, please. And this is how they kind of show. And then they will tell you the rating, very high, low, medium is how the Auburn index shows. No aggregates is 0, you get a 0 on the no aggregates on the left side. Very low will get you as very low index rating. And then therefore that kind of belongs to an area which needs a significant improvement. But let me tell you, in our state, we will be mostly in this area, except for some of the nutrients like phosphorus. Several of the soils have phosphorus high, in our soils, because we have applied a lot of phosphorus over the years. That kind of sits there. There's a legacy phosphorus even in Lake Okeechobee, all that it drained from south of Orlando. So that's how it is. So based on this data, they will provide you some recommendation on how to manage this. Next slide, please. So here Auburn recommends mostly, this is all for the major crops, commercial crops, not for landscapes. So they kind of suggest some BMPs, putting some soil erosion restrictions and other conservation measures. But for Florida, we don't have a lot of erosion, we don't have a lot of runoff because they're all level soils pretty much. There is not much elevational differences other than in the Panhandle region. Next slide, please. Cornell soil health. This is another soil health, this is about $95. A lot of our people have sent samples to this and other labs. And then these are the various things like soil pH, organic matter, some nutrients, pretty much the same that we see both places, a protein test, water capacity, and some of the hardness, people have to provide a penetrometer, see how hard the soil has become. Again, like I said, a lot of these are packaged for commercial agricultural, production systems. Next, please. So here again, they rate yours, the red ones are like, need this or that. And then the others are like 100%, they're green, they're looking good. The overall quality, they kind of score the quality at 44, and then they say it's low. So it has to be a certain number before it is high, it becomes higher and better. So you can see the textural, the class they are dealing with is like silt, they have 65%, clay 15%, sand 20%. 99% of our soils that we have tested in our soil moisture lab in Florida test about 95% as 95% sand. So there is only 5 more percent that has a room for clay or silt. So it is sometimes it's more than 95, sometimes it's 98% sand. That's what we are dealing with. Next, please. Now, how does this apply to Florida landscape? Next, please. So we have this problem. We ran into this issue. We've been working on this and talking about this for some time, a good while, like 4 or 5 years or so, since this became extremely an emphasized area. That is, this is the deal. We can do all the tests in our laboratories. That's the easy part. So even if we tested, interpretation will become very difficult, because what is the relevance to Florida? Like, aggregates, they don't form aggregates. CEC we don't have. Organic matter is limited. So how does this work for us? When you put the same Florida soil on this particular chart, assessment chart of either Auburn or Cornell, we will be rating always poor. But then we have very immaculate landscapes. Our fruit and agriculture, vegetable production, we are number 2 in the country. So what happens there? There's a lot of management. Basically, we have to understand our system, what we have, and then create a solution for that, and not necessarily run a test for the soil health yet, because we don't know yet. Because once we put all these different tests and parameters together in a comprehensive manner, we have to be able to understand what exactly we are talking about. What is this soil health? What does this mean? And what do we do with that? What do we do now? Now I'm poor. What do you want me to do? Do you want me to dump a truck of organic matter on my yard? How does this work? So these are the things we are we are having little difficulty right now comprehending, and we are looking for a multi-locational applied research project in the yards and in the fields to be able to, connect back to this soil health completely. Not that we don't know, not that, the only thing is how do we put it together, because Florida is unique. It's unfortunately or fortunately, it's very different from the rest of the country. Next, please. So practical suggestions, this is from my experience and then what we have seen around for the yards, okay, particularly for the yards. If possible, please find out what the soil texture is, okay? But this particular test is a little expensive. It is not done necessarily at the soil slabs. These are done at this is a physical parameter. This is done at the physical moisture labs. So this may be in Florida, this test costs $30, just the soil texture. Tell you how much sand, how much silt, and how much clay there is. And then if they come back to the chemical part, you have a soil pH. You should always know soil pH. If there is one chemical parameter that you ever want in your yard, it is the soil pH. And then how do you want to separate out these different pH tolerant species? Because St. Augustine, for example, needs 6.5, Azalea needs 4.0, or a blueberry plant needs 4.0. For a blueberry needs 4.0. So what do we do? How do we separate them? So we talked about management zones, which the Florida Friendly Landscaping also does in a lot of their recommendations. Also look at that. Irrigation. How often do we irrigate? We irrigate low, because the more you irrigate, the more losses there will be, because we are sands. They don't keep this water, or they will wash away the nutrients. So, but at frequent rates, apply small doses, more like spoon feeding, and then, apply fertilizer applications. Always formations and the local ordinances right now nowadays, you do not want to, if you're a homeowner, please follow that. If you're a landscape, of course, they are already trained, a professional, they will do that, a company. Same thing, when you, please consider straight fertilizers. What do I mean by that? If there is a recommendation for 1 pound, please go to the stores and buy only 1 pound of, fertilizer. Do not buy 10, 10, 10, 608, 8, or 15, like that, because those are not straight fertilizers. Blended fertilizer have other nutrients in it. But when we are recommending nitrogen only, please purchase only nitrogen and apply only nitrogen source. This will be a little bit more expensive, but if someone is a good steward of land and what they do. They take pride in how they are doing. This may be one thing that they want to consider, and not go for 10, 10, 10 every, because I know many of my friends and several of them here do go just buy 10, 10, 10 off the shelf in a local stores, and then just walk around the yard, not exactly knowing how much amount there is in the bag, the amount, and how much area they're actually spreading it on, and how does it relate to the amount that is recommended. So there are some things that our faculty can help, our master gardeners can help, our landscape professionals do know all that. So they do consider everything and then they apply accordingly, but some people may not necessarily know this. Then if you are using organic sources used for nitrogen, like compost or other nutrient sources, look for the nutrient concentration in those. Do not just bring a bunch of compost and dump it, because first thing, like I told you, you need to know the CN ratio, whether or not it's releasing, because I have several complaints that come. People call, said, oh, we applied compost, it's not doing anything, actually killed my plant. That's because the CN ratio may not have been at the right level, because that's called the cured compost. Composts have to be cured for some time. So this CN ratio falls in place. And sometimes, to correct that, we also apply a little bit of urea or other ammonium nitrate type of fertilizers to correct that ratio. Then it will start releasing the nutrients. So please know that. And mineralization times should be considered. If you are in South Florida, there is a high amount of mineralization because there is a lot of sunshine and rainfall, versus in the northern part of Florida, particularly in the Panhandle, it's cooler there. Sometimes in the cooler season, the mineralization will be slower. Always, next one is always, please, please, please recommend soil aeration. It may be a little expensive. You may have to hire somebody to do it, but this is what's happening in our soils. That is, they are applying, a lot of homeowners are applying some organic stuff in there. And then our grass roots form a tuft, which is a thick thatch of roots underneath. That kind of blocks the water movement and nutrient movement, cycling, and the air movement. So periodic aeration is extremely important for our soils. Then there is a minimum bulk density always required. Don't consider lower bulk density is always good. So in the formula I showed you, if approximately 1.3 to 1.5 bulk density grams per centimeter cube will be excellent. If your number is 1.3 to 1.5, you're doing very good. That's what you need, because that also need to provide the stability for the roots and anchor support for the roots. And then also it will give you some aeration and water flowing conditions through it. So this is extremely important. So there is a minimum bulk density required. So sand is important. Don't consider sand is bad. Sand is good, but it improves aggregation if there was some organic matter, if there was some clay content in it, or silt for that matter, much better silt. So always keep the grass or your yard with a grass or plant covered, because that's going to cause a lot of other issues very soon. Next, please. So we recently have proposed for the Center for Soil Health and Sustainability. And several of you have sent me emails supporting this idea. We will be we will be sharing more information. Over 100 faculty, the state agencies, and several from the industry are in support of this center. This will be located in Gainesville in our department, ours being the soil and water science. I wanted it to take the lead. So I will be the director, and I have a microbiologist who will be acting as my associate director. And this has already gone to the deans and sent back to us for revisions. We have revised and resubmitted back to the deans. So it is awaiting final approval. This will go all the way up to the provost. And because of the COVID this year, unfortunately, there has been a lot of little bit delay. But hopefully early next year, once everything settles down, this will be granted. So this will bring a lot of focus statewide. And I already contacted several people in several departments that are willing to come forward and then start comprehensive work. on these, and then we can also, we have some few right now, some grants also that are helping, but not in a coordinated fashion. Hopefully that will happen soon once this center comes in place. Next, please. So any questions and discussion, I'll be very happy. This is my contact. You can always contact me anytime. I will be happy to answer your questions. And then several times I have come out to several of the counties. I do come out on a regular basis, talking to the master gardeners, talking to the agents specifically. Yes, and I've seen a question earlier, PHS can be done at the county level. Most counties have that option, and please check. If not, we can help you with that. And some of them also come up here, wanting help with their soil pH meters, because sometimes they are not calibrated well, but our lab can help all that. And any questions, please? Thank you.
Sure, Dr. Mylavarapu, there's a question came in. Can you please recommend a name fertilizer for both lawn and another for plants that is good for soil health?
Yeah, if you are talking about inorganic fertilizer, the main thing you want to look for is the straight fertilizer. That's what I want to emphasize. Do not apply something, a fertilizer blend that has nitrogen, phosphorus, potassium, everything, when you are only trying to manage nitrogen, when you are only trying to manage potassium, when you are only trying to manage phosphorus. There are many sources out there in your stores. Unfortunately, they are not up front. You got to pretty much ask somebody to show you that, or if there is a little fertilizer store, they will bring you that. One of the things is ammonium nitrate. Nowadays, it has become hard to get some of that. Urea is another straight nitrogen fertilizer you can apply. But with urea, just like any other nitrogen fertilizer, please be aware, if you do not incorporate it, don't put it under the soil and leave it on the surface, more than 50% of that urea will be volatilized and lost. So please try it and not to do that. If you ever apply any of these nitrogenous fertilizers, please apply under the, will apply and then put some soil cover over it. Any other fertilizer you apply, please water it down immediately. It needs a small amount of water. Please water it down. Do not leave anything on the surface. So there are phosphorus fertilizers all by themselves. More than likely, you will not need any of those. But potassium in Florida is always required. Just to give you some statistic here, more than 60 to 70% of the soil tests come back with low or medium potassium levels. So that's another thing that you want to apply along with nitrogen on small doses if possible to avoid excess loss, because it leaches very quickly, just like nitrogen. So please avoid complex fertilizers.
Great. Another question that came in, best place to get soil analysis locally in Broward County?
There used to be an A&L lab in Pompano Beach. I'm not so sure. It probably changed its name because I know the owners personally, Dr. Large, but I think they have moved on. So there, it may be operating under a different name, but if you look at still, if you can Google on for A&L lab, it might, reconnect you back to that particular new name and the new lab. Or you can always send it to Gainesville. Gainesville always usually get it back in 2 or 3 maximum days.
Fantastic. Another question came in. Does an organic all-purpose fertilizer work well?
Yes, organic fertilizers are good overall, but here is the question. Like I talked to you earlier, there is something called this mineralization aspect. Unless the organic nutrients turn into mineral nutrients like phosphorus, organic phosphorus should turn into phosphate. Nitrogen, organic nitrogen should turn into nitrate or ammonium. Only then, only those two kinds the plants can take up or roots can take up. They cannot take any organic nutrient up. But potassium does not have this issue because it is dug up from the soil. It's in a mineral form. To begin with, it's easily soluble. But for nitrogen and phosphorus, you have to keep track. You have to look at those numbers on your bag. And then you will see how and then you have to be able to calculate for your yard and the amount of that is recommended. Usually these organic sources have lot less nutrient at any time in that bag. So therefore, it may not always necessarily be enough or adequate for the plant to meet the plant requirement. So a lot of people, what they do is they use a combination of blended of synthetic fertilizer or inorganic sources and organic sources, 50-50 type or 75-25, because that will help meet the requirements by the plants and not provide a lag or some other issues with the plant production. And one thing, just to give you a rule of thumb, the Florida Department of Environmental Protection, FDEP, they consider any organic source that you apply, roughly 50% of that content is available the first year, particularly the nitrogen and phosphorus. The other 50% may be available the following year or season. So you're only then talking about 50% of availability at any given time. So please keep these in mind when you consider organic, because it may not give the plants or the grass enough fillip to move up the chart.
Terrific. I think that got all the questions. Dr. Mylavarapu, I want to thank you for a great presentation. And, again, your email was shared there. So, please, participants, feel free to contact him if you have questions. And also, as you exit today, make sure that you take part in the survey if you can. That data is real important to us. So everybody, thank you again for participating, and join us next month for another webinar. Take care and have a great day.
Thank you very much. Thank you. Yeah, thank you very much for all of you for joining. And any time, if you have any question, or if you want me to come down to your, not during this COVID time, but once we are clear, I would be very happy to come down and then sit with you, talk with you. Or if whenever you're Gainesville, please visit us. The soils lab is a little bit away from our main department. It's near the horticultural science department, Fifield Hall. They have some visitor parking. We have continuous visitors coming all the time. We give tours, so you can see what happens in the backgrounds. You may just send a sample and then you may end up getting a report, but you might be interested at some point what exactly happens behind the scenes here. We might want to get an idea about that too, and we'll be happy to show you around and talk to you a little bit about your issues where you're located. Thank you very much.
Fantastic. Have a great day.
Have a great day. You too. Thank you.